Science Beetle.
So if we take an element, we know that if we break this down, we are going to make, or we're going to see that it's composed of atoms. And these atoms then, if we were to take a particular element, let's say we take oxygen, we take hydrogen, and we take chlorine, for example. And let's pretend that I have a container. And in this container, let's say that I'm only going to put oxygen atoms. So in here I have all these oxygen atoms. Or I have pure oxygen. So essentially one of the things that we notice though is if we come in here and we look at the atoms, we're going to find that the atoms here, the mixture or whatever is contained inside the container is going to be what we consider pure. And the reason that it's pure is because all the atoms that are in here are all oxygen. There's nothing else but oxygen. So when we say pure, the other thing that we're saying is that this is homogeneous. Okay? And so essentially all saying that these are all of the same type, all the same atoms. They're of similar structure, appearance, and have properties. The atom then, if we were to compare this particular atom, which is an oxygen atom, to the next one, we're going to find out that they're the same. And if we compare those to the one next to it, or the one next to it, is that they're the same. Eventually we continue this process of comparing all the different atoms, all these atoms to one another. What we find is that in a mixture, or not a mixture, but rather if we have a container of only oxygen atoms, what you find in the container is that these pure atoms, they're all going to be identical. Okay? That means that they're all the same. Now, what happens when, for example, we say that we want to add some hydrogen in here? Well, if we add hydrogen into the mix, things are going to be different. So if I had some hydrogen here and some hydrogen here, and I'm just adding some hydrogen atoms in here. Now, the mixture now is no longer pure at this point. And the atoms that are in there are no longer identical. So what we have created is no longer homogeneous, but rather we've created a heterogeneous mixture of two different types of atoms. So what we've got here is we've got hydrogen atoms and we've got oxygen atoms. And if we just looked at the types of atoms, then they're different. And essentially, if I were to compare the oxygen atoms that are in blue with the atoms of hydrogen, which are denoted in red, we would already see that we have different types of atoms. And one way that you can actually see this is if I actually draw a structure for you as to what it looks like, what the oxygen, the hydrogen, and perhaps the chlorine atom look like. And so let me do that for you now, and then we can answer the question whether all atoms or all elements are the same. And the short answer, before we even get to it, the answer is going to be no, they're not the same. But let me show you why they're not the same. So if I take the oxygen, and I'm just going to put the symbols up here just so that we're aware. The oxygen is going to have an 8. It has 15.9994. The hydrogen is going to be up here. Hydrogen has a symbol of H. It's got a number of 1, and the weight is 1.008. And if I do the same thing for the chlorine up here is going to be, has a symbol of Cl. It has a 17 for the atomic number, and it's got a mass number of 35.4527. So essentially what this all means is it all relates to the different types of information. So we know if we look at the numbers up here for oxygen, for example, it has 8. That means it has 8 protons. If I look at the hydrogen up here, I know that it has 1 proton. And if I look at the atomic number for chlorine, we know that it has 17 protons. Okay? And there is a way to calculate the number of neutrons and the number of electrons for these. We'll cover that a little bit more in detail, but for now, let me just draw the structures for these different types of atoms, and then you can compare. So here you have the structures, and essentially if you look at this, what we've got, and I've already written the numbers here down for you, we figured out for oxygen, which is the one here, this is oxygen here, and oxygen is going to have 8 neutrons, and it's going to have 8 electrons. And like I said, in the later lesson, I'll show you how we calculated this. But essentially, you've got 8 neutrons and 8 protons here in the nucleus, and the nucleus is right here in the middle. Okay, and then the electron shell, you've got 8 electrons. So let me just circle those for you. You've got 2 in the center, And so let me back up a second here, and I'll just circle them individually. And so we've got 1, 2, and the first orbital, and then 3, 4, 5, 6, 7, and 8 are the number of electrons, and so you see that there. Hydrogen, right here in the middle, hydrogen only has 1 proton, so we see the 1 proton. It does not have a neutron, and it has 1 electron, and there's the electron there. And chlorine will be the one at the very end, and so chlorine has 17 protons. We calculated that it had 18 neutrons, and we find those in the center. And then if we count the electrons all the way across, we'll find that we have 17 electrons that we need to find places for. So we go 2 in the first orbital, there's 1 and 2, and then if we go into the second orbital, we're going to find that we have 8, and let me just circle those. There's 2, 4, 6, and 8. 8 plus the 2 in the center is 10, so it means we have 7 more electrons to place. Here's 2, 4, 6, and 1. Notice that it's only 1, and right here we're missing 1, so this is going to be the -1 charge. The -1 charge associated with chlorine indicates that it's missing 1 electron. And that's just a little bit more information. But anyway, from what you can tell from the structure here, the different atoms don't even look alike. So you can tell that just by looking at the number of neutrons, the neutron number is all different. So neutrons for oxygen is 8, neutron number for hydrogen is 0, neutron number for chlorine is 18. So obviously, just right there, 8 is not equal to 0, and it's not equal to 17. Okay, so that's the first thing. And then obviously just looking at the general structure, the hydrogen atom right here in the middle is significantly smaller than the oxygen atom over here on the left, and it's significantly different than the chlorine atom over here to the right. And so when we ask the question, are all elements the same? The short answer is no, but now we know specifically because the atoms are different, and atoms are the subcomponents of elements. We know that atoms from different elements are not going to look the same. And if they don't look the same, then the atoms are not the same. So when we ask the question, are all atoms the same? The answer is no. And by virtue that the atoms are all different, when we're talking about individual elements and comparing those atoms of those elements with atoms of other elements, we know that if the element is the same, all the atoms in that element are all going to be identical. But when we're comparing atoms from one element to the atoms of another element, they're obviously going to be different. So far what I've talked about has been the elements, the subparts being the atoms. I've shown you a very brief introduction on how atoms are very different from one another depending on which element they're from. And in the next lesson, I want to go a little bit deeper into the atom and explain a little bit more how I kind of calculated all these numbers here at the bottom with the neutrons and the electrons. And I want to explain that a little bit better so you understand it before we move on into a little bit more complex things. But for now, I kind of want to stop it there and then have you join me at the next lesson, and we'll pick it up from there. All right, see you soon. And don't forget to subscribe.